All right, y'all. So like I said, this is 9.7. And it deals with applications. And we're going to be looking at growth and decay. So growth is when something's increasing over time, and decay is when it gets smaller and smaller over time. So the growth we'll look at sort of like population growth and investments. So we looked at investment problems in the earlier sections, and they had like semi-annual, compounding, annual, monthly, and so on. So this section, we're looking at continuous compounding. So I'm going to give you some formulas for growth and decay. So y'all, exponential growth can be given by the formula P of T equals P subscript O. So that means that's just a subscript for the P. It has no relevance other than that. And then we got E, and then the exponent K times T. So in this case, the P of O, that's your initial population or initial amount. So that's our initial population. Or if I'm looking at investments, that would be my initial amount. Right, this P of T, that's the population or amount at any time T. So that's the population at any time T. So if I want to look for 5 years, I'll be finding P of 5, population after 5 years. Okay. All right, then you got a K here. K is what we call the growth rate. Now, if you're dealing with money, that would be the interest rate. So the growth rate is how much it grows per year. And then T is the time in years. Okay. Now, E, remember, that's our Euler's number. And that's sort of the E we've been playing with when we're doing the natural logs. Okay. So growth. Now, decay. When we look at decay, it's the same exact formula, but since it's decaying, that K will be negative for decay. So for decay, it'll be P of T equals P initial times E to the negative K times T. So the only thing is the growth rate, or what they call the decay rate, if the growth is getting smaller, that's the decay rate. And remember, it's negative, okay? And that's the only difference between these two formulas. Now, I'm going to give you a few more formulas, and then we'll start working these examples. So we got what we call double time. So double time is the amount of time it takes for your population to double. So that would be given by this formula, T. So double time is a capital T, where regular time is a small t. So T equals the ln of 2 divided by K. So remember, capital T is double time. And then y'all, K is still my growth rate. Or decay rate, depending on what type of problem I got. So it might be wanting me to find the time it takes for it to double, or the time if it was decaying for it to go in half. Okay. Now, this would be the formula I use to find the amount at time T. But notice, I'm going to give you formulas to find K and T if you ever need to. So to find K, you would use this formula. K equals the ln of your PT, your final amount divided by PO, which is your initial amount. All of that, y'all, divided by T, which is the time. And then if I want to find T, so say they're giving me everything and they want me to solve for T in my problem. T can be found by finding the ln of your P of T divided by PO, which is P initial, over your K. So these two formulas are the same, except this one you're dividing by T to get K. This one you're dividing by K to get to T. All right, y'all. So that's the formulas you want for this section here, okay? All righty, so let me get my problems here. Okay, y'all. So for the first example, they say in 2012, the population of a city was 5.31 million. Then it tells me the exponential growth rate was 2.49% per year. So this has 4 parts. So for part A, they want us to find the exponential growth function. So y'all, when they say that, they want us to find the formula. So we're going to use this formula to come up with what we need for our problem. So MATLAB will give you the P of T part of this. We just got to fill in for everything else. Okay, so first thing I need is my initial amount, my P of O, my initial population. Well, y'all, they gave us the initial population right here. They said the initial population was 5.31 million. So our initial would be 5.31. Now, remember, we're assuming anything we get out of this will be in millions, since that's what the problem had. So then our PO is the 5.31. Then we put our E. Now we find our exponents. K, well, K was this exponential growth rate. So they gave me 2.49%. But remember, to use it in the formula, you got to turn that percent into a decimal. So I'm going to pull my chat up. Do y'all remember how to turn 2.49% into a decimal? All right, so I'm going to help you on this first one, all right? It's the same thing we did in 9.3 when we turned those percents into a decimal. Remember, we got to take that decimal and move it left twice. So if I move it left twice, oh, now it's popping up, and I see what, a 0.0249. Good job. So we had to move it left twice, add a 0, okay? All right, so that'll be 0.0249 times T. So that's your exponential growth function. If you know how many years you're looking at, you would plug in for the T, and then that would give you your amount. All right, also for B, they say estimate the population of the city in the year 2018. So for this one, they want me to estimate the population and come up with an amount. So I need to figure what to put in for my T. So y'all remember, they're wanting me to start at 2018. My initial population was from the year 2012. So we just need to figure out how many years passed since 2012. So we would take our 2018 minus our 2012, and that's going to give us what, about 6 years. So we want to know how much this population has grown in 6 years since 2012. So we're finding P of 6. So our formula was 5.31 times E to the 0.0249 times 6. And y'all, I'm going to go to my calculator and just punch that up. Now, here's the thing. On the older calculators, when you hit second LN to get the E, so second LN, that'll get you the E. On the older ones, it'll give you the E and an opening parentheses. On the older ones, you have to put in your 0.0249 times 6 and close those parentheses. If you don't close the parentheses, it won't give you the right answer. So on the older calculators, when you hit the second LN to get the E, remember, close those parentheses after you do your multiplying. Now, newer ones, it kicks it up. So let me show you on the newer calculators. That's the only one my screen will do. When you put this in, you got 5.31. I hit second, and then the LN button by the 4 to get that E with the exponent. Now see, on the newer ones, it'll keep the little cursor up there in the exponents. So you can just punch in the 0.0249. And then multiply by the 6. Just remember the older ones, it don't kick the cursor up like that. So you gotta use the parentheses and shut them on those ones, okay? All right, y'all, we're going to estimate this one out to, looks like 1 decimal place. So we're going to hit enter. So I get 6.16. I'm going to round that off to 6.2. Now remember, this is in millions. So after 6 years, the population of this city went from 5.3 to 6.2. And then the math lab will say millions here. So all you got to do is put in that 6.2, okay? But remember, that would be in millions. All right, let's see what C wants. So now C says the population of the city will be 9 million in about blank years after 2012. So they're not wanting me to find the year, they want me to find how many years it took after 2012 to get to 9 million. So when they ask you a question and they want to know in an amount, how long it takes it, that 9 million is going to be our P of T. That's our final amount. And what we're actually looking for is that time. And y'all, if you remember, I gave us a formula to use when it wanted to find the time. Okay, so the time, remember, equaled the ln of your P of T over your P of O divided by the K. We know our K, which was 0.0249. P of T, which is the ending amount, will be the 9 million. We know the initial amount they gave us was the 5.31 million. So y'all, we can fill into this formula and we'll have the LN P of T, which was 9 million over our initial amount, which was 5.31 million. All that divided by K, remember, has to be in decimal form. So that was 0.0249. Now, when you do this problem, you gotta put that division inside parentheses before you divide. Okay, now we're going to round this one off. Let me see. Looks like this one will be rounded off to 1 decimal place. All right, y'all, so let's go to the calculator and I'll show you how I punch that in. So I would hit my LN button first. It opens parentheses. I'm going to put my 9 divided by 5.31. I'm going to close those parentheses and then I'm going to divide by my 0.0249. So remember, we're rounding this 1 decimal place. So it looks like that's going to round to what, a 21.1. So y'all, that means in 21.1 years, our population would have gone from 5.31 million all the way up to 21 million. Right, let me pull this camera down just a little bit for this one. So D wants to know the doubling time. So how many years does it take my 5.31 population to double? So remember, doubling time, we got that formula right here. T equals the ln of 2 divided by our growth rate, which was our K. And y'all, we know everything we need. So ln of 2 divided by that K, which was 0.0249. Now we do know it's got to be more than how many years did this one pass? 21 years, and it was at 9 million. So it's going to have to be a little bit more because we're looking at like 10 point something million, right? So here we go. Let's do this. ln of 2 divided by 0.0249. Let's see, I did that. And I ended up with around 27.8. And we knew it had to be more than the 21 it took it to get to 9 million, okay? All right, y'all, so that's using that formula for question 1. Y'all got any questions?
Yes, in part C, we are only rounding to the 10th.
Yeah, and it'll actually tell you when you're looking at the answer blanks, it'll say round to 1 decimal place. Some of them will say round to the nearest years and stuff like that, okay?
Okay, all right, thank you.
All right, y'all, so number 2 was a table they wanted us to complete. So number 2 says complete the table. And really, this is just a, whoops, let me pull that camera back up. Really, this is just a table looking at doubling time and growth rate. So they have the population in the first column, then the growth rate, which is our K in the second column, and then the doubling time, which is our capital T. So they're looking at the population of country A and country B. Now for country A, they gave me a growth rate of 1.9% per year. They didn't give me country B's growth rate, so we're going to have to find that in a little bit. Now, on the doubling time, they didn't give me country A's doubling time, but they gave me country B's doubling time, which was 43 years. Now, MATLAB is going to have that percent there, and up here it'll have the years. So all we're going to do is find the numbers. Now look, looks like the growth rate, we're going to round to one decimal place like they did and put it as a percent. So remember, we're going to get a decimal out of it when we do it in the formula. So we got to turn that decimal back into a percent when we put it in the table. And then doubling time, we're going to round to the nearest year. So let's find country A's doubling time. Remember, we had that formula for country A. So I'll call this doubling time. And I'm just going to put a little a there because I'm doing it for country A. That's going to equal to ln of 2 over the K. Well, remember, K is 1.9%. So y'all, what would that be in decimal form for me to put into my formula? So I'm getting a 0.019, looks good. So put in a 0.019 here. Whoops. 0.019. All right, so let's figure out ln of 2 divided by a 0.019. And we're looking for years, okay? Now, looks like I got that one rounded out when I did it to 36. So let me check that real quick. So I had a ln of 2 divided by. Now, when you put in the ln of 2, remember, close those parentheses and then divide by the 0.019. And yeah, 36.4, which rounded to the nearest year of 36. All right, so I will put my 36 in for that box. Now we're looking for the growth rate percent for country B. So remember, to find the growth rate equal to ln of 2 divided by its doubling time, which was 43 years. So now I'm finding the K for B, country B, okay? So I just use subscripts to sort of let me know doubling time for A and the K for B. All right, so when I punched that one in, y'all, I ended up with a 0.01612. So first I'm going to turn it into a percent, and then I'm going to go one decimal place. So to turn a decimal into a percent, you move the decimal to the right. So that's basically going to give me a 1.612%. So we're rounding one decimal place, which would be the 6. I got a 1 after it, so that will stay a 6. So here we would put our 1.6. So remember, turn it into a percent by moving that decimal back to the right. Once you do that, then round it that one decimal place, okay? So y'all, these really aren't bad. You just gotta keep that first page of formulas that we had, okay? So here's one with an investment. So suppose $10,346 is invested at an interest rate of 5.1% per year, compounded continuously. See, if it was compounded semi-annually, annually, we would use those formulas we learned in 9.3. where we had the n and all that fun stuff, okay? But since they're continuous, we use the formula with the e. So y'all, part A wants me to find the exponential growth function. So like we did a while ago for 1, they want me to find that formula. So we're going to find the exponential growth function. So remember, interest rates, growth rates are the same thing for this problem. So they still use the P of T. So MathLab will give us the P of T. We got to come up with the rest of it. Well, we know our initial amount, that was that 10,346. Remember, then we had our E. Then we had K times T. We need to know what the K is, and then we'll put the T and be done. So remember, K is 5.1%. Y'all, I need that turned into a decimal. So I got one coming through, 0.051, good job. So that would be 0.051 times T, and y'all, that is our exponential growth function. Now here's where I'm going to have fun on the calculator. So this one wants to know, what is the balance after 1, 2, 5, and 10 years. So they want me to know what the balance will be after each of these years. Now, if you're doing it by hand, all you got to do is put a 1 in for the T, punch that in the calculator, see what you get. Then put a 2 in for the T, punch it in the calculator, see what you get. But y'all, I'm going to use the graphing part of this. So I'm going to show you how to do this pretty quick on that calculator. Now, this one, we're going to round 2 decimal places like money. So y'all, the easy way to do this would be to go put this graph in your calculator and then use that value function that I told y'all about. So on the calculator, I'm going to graph it, y equals. Then I'm going to hit second trace and go for the value. Okay. So here we go. We're going to run to our calculator. All right, so let me clear that. So I'm going to go to y equals. And I'm going to put in that function that we had, 10,000. $346. Now I'm going to hit second LN to get the E with the exponent. So second LN brings up the E with the exponent. And then I had 0.051. Now remember, if you use y equals, you can't use a T here. You got to use the X. Okay, because they always assume X is the variable when you're going to graph this. And y'all, I don't even care about the graph. I just want these values. So once I got that put into Y1, I'm going to hit second, and trace is the 4th button on the top row. That brings up a list of things. I want to find the value, so I hit enter because it's highlighted on 1 already. Now remember, down here to the left, it says X equals. So I had 1 year, so my first one would be 1. I would hit enter. And y'all look at that. We got 10,887. We're going to round this 2 decimal places, would be 33. Now, T equals 2 is next. So I would hit second trace again to get the next value. Second trace. Enter for value. Now I want X equals 2. Hit enter. And we're gonna round that off 2 places. So this is 11,456. Point. So let's see. 8 is in the last spot. It's got a 9 after it. So I'm gonna make that 8 a 9. So that'll be 0.99. Then I'm gonna hit second trace again. Enter for value. Y'all, this is one of my favorite things on this calculator is being able to do this. And then hit that 5 and enter. So now I'm getting 13,351.1. So now my second one has a 6 after it. So I'm gonna make that a 2. So that gives me 12 cents. And then finally, we'll hit second trace, enter for our value, put in a 10. Whoops, let me go back. Make that a 10. And enter. And notice these amounts better be going up each time because this is an investment. So y'all, this one looks like what? 17,229. 0.103. That's going to be a 0.10. So 10 cents on that one. So y'all, that's the trick on this. Remember, by hand, you could put those numbers in and punch that straight on the front of the calculator. Or if you was lazy like me, graph it in Y equals, and then use that second trace, okay, and get the value. All right, y'all, let me see what I got here next. Okay, so this one's sort of going to be one that has a little decay to it. So they give us a table. And in the table, it's got the year and then the percent of adults who are married. We'll call this the percent of married adults. So they give me the years of 1960, 1980, 2000. Then it goes to 2010 and 2012. So the percent that was married in 60 was 68.6%, 56.4, 51.4, 47.6, and then 40.6. So notice the percent of married adults, we don't know what country, but it's declining as the years go, okay? So first thing they want us to do is use the table for 1960 and 2012 to find the value of K. All right, so let's see, 2060 is right here. 2012 is right here. So remember, we had a formula for K. Remember, K equals the ln of your PT divided by PO, all divided by your T. All right, so we take the ln. Y'all, the ending amount is the 40.6 because that was in 2012. So that's going to be my P of T, 40.6. 1960, we had 68.6. That was our initial amount, all divided by T. So we got to figure out how many years y'all have passed from 1960 to 2012. So y'all subtract that and let's see what we get. We should get oh, what's that? 40 to 2000 and then 12 more. So it looks like T would be 52 years for this. So we're going to divide by 52. So when you divide that, we end up with a negative 0.0101. Now, in Math Lab, all you're going to put is the 0.0101. That's decay. This formula automatically has the negative in it. So when you put Math Lab, 0.0101 is what you want to put for your K, okay? Do not put the negative in Math Lab. And then it'll have the formula you filled in, M of T. So they're using M's this time. Would be your initial amount. Remember, my initial amount was 68.6. E. Now, Math Lab will have that negative there. Or if it don't, you got to put the negative, but make sure you make this a negative 0.0101. And then T. That would be our exponential growth model for this problem. So I'm trying to look on Math Lab. They don't put the negative in here, so when you put it in the formula, don't put the negative when you find decay, but put the negative in the formula because remember, decay has a negative in front of its K. All right, y'all, B on this says estimate the adults married in 2015 and 2018. Well, look at this table. In 2012, we was at 40. So 2015 and 2018 are coming later than that. So we should have a less percent of married adults in this country. So y'all, here we go. Let me find my notes again. So let's see. Let's try 2015 first. So 2015, we're looking for M of 55. Because remember, if it was 52 years to 2012, add 3 more, we get to 55 years. So I guess they're using M in this one instead of P for population. They're using M for married adults. So they always try to match what they're looking for with these letters. All right, so that would be 68.6. So I'm just using this formula now and putting in for my years. So 68.6 E negative 0.0101 times 55. So y'all, let me see on this one. They want me to round 1 decimal place. So when I punched that one in and rounded out, I came up with a 39.4. So less than 40% people married in this country in the year 2015. And y'all do the same thing for 2018. That's 3 more years. So that's going to be 58 years. So we're finding the married people after 58 years. Same formula, 68.6 E negative 0.0101 times 58. And guess what? You're going to expect it to be even less than 39.4 because it's 3 more years later. So rounding 1 decimal place, y'all, when I punched that in, I came up with a 38.2. Okay, now check this out. At this decay rate, so see how it's a decay because it's going down over time. So at this decay rate, in which year will the percent of married adults be 30? So y'all, they want to know, when will we be down to 30%? So that is my ending amount, right? So remember, we had a formula that we could use to find the time. The time in years was the ln of my P of T over my P initial, all divided by my K. Now I know my K is 0.0101 negative, right? So now that's the ln. P of T is an ending amount, that's going to be the 30%. The beginning amount was the 68.6 that we use in our formula. We'll take that and divide by K, which is a negative 0.0101. So this will find the number of years, but then I got to go back and add it to 1960 to figure out the actual year, okay? So y'all, when I punched all that in, I came out, rounding to the nearest year, I came out to 82 years had passed. So what you want to do is take the starting amount, 1960, plus add 82 years to that, and that'll give you the year 2042. Okay, so this one wanted to know the actual year. So when you found the amount of time it passed, add that to that starting amount. So over time, this country is just getting less and less married people, okay? And y'all, that's the trick on these, is just playing with them little formulas, okay? All right, so let me run these last two by us. So number 5. So example for number 5, the number of farms in a certain state. So the number of farms in a certain state has declined continuously since 1950. So in 1950, there were 81,242 farms. And in 1995, there were decreased down to 22,107 farms. So assuming the number of farms is decreasing according to an exponential model, find the value of K. So find the value of K. And write the exponential function. And this one will give you an A, B, C, D answer. And it has them all negative, so you ain't got to worry about the negative. You just got to figure out which one of these numbers yours rounded to, okay? So to find K, remember we had a formula. K equal to ln of your PT divided by your P initial all over the number of years. All right, so bring over that ln. You know, they gave us the final amount was 22,107 in 95. So that'd be 22,107. The initial amount in 1950 was 81,242. All of that divided by the number of years. So y'all, let's see, from 1950 to 1995, that's what 45 years? So we divide by 45. All right, y'all, so let's go push this on the calculator. Now, looks like they're rounding these answers all out to 3 decimal places. So that looks like what all the answers have. So let's round this out 3 decimal places. So I need to get my screen back. So second, quit that. So I do my LN 22107. Divided by 81,242. Close my parentheses and then divide by my time, which was 45 years. So remember, this should give me a negative number because I'm decaying. And looks like I'm getting, let me move this chat out of my way. So if I'm rounding 3 decimal places like they did, that'd be a 0.02. The 8 has a 9 after it, so the 8 becomes a 9. So that'll be a negative 0.029. So I'm going to show you how they do the answer on that. If you can come up with that negative 0.029, notice on these answers, they got a negative 0.028, negative 0.033, negative 0.029, which we needed, and a negative 0.030. So if you get to negative 0.029, there's only one answer that has that, so you're good to go once you choose C and be done, okay? All right, y'all, the last one. So there are currently 55 million cars in a certain country. Decreasing by 1.7% annually. How many years until the country has 30 million cars? So they started with 55, going down to 30. So this is probably one of them countries. I seen something on the news where there was a country, they were starting to ride a lot more bicycles and making the city bicycle friendly. So something like that could cause a decrease in actual cars. But we're looking for years, remember? So years, we would use our formula, T equals the LN of our amount divided by our initial amount, all of that divided by my K. So we know what there is because the ending amount was the 30. That'll be my P of T. The initial amount they started with was the 55. And then K we'll figure out from that 1.7%. So you are going to take the LN of PT, which is 30, over P initial, which was the 55. All that will be divided by K. So y'all, you got 1.7%. So what's K? All right, so I got an answer. Looks like a 0.017. Good job. So that's going to be 0.017. All righty, so listen. One of y'all punch this in and see what you get. I want to see if y'all can work that calculator right. And you're rounding it to the nearest year. So you're not going to have any decimals on this one. Round me to the nearest year, y'all. So I want to know, they're going to give you ABC on this. So are you going to get 36 years, 189 years, 3 years, or are you going to get 15 years? Oh, I see an answer coming on. Let's see. Oh, good job. That's what I got. Rounding to the nearest year would be 36. Good job. So that's how you want to do that calculator, okay? No, that's the 6 problems that you're going to see for homework. So remember, use them formulas I gave you on that first page. And these problems are not bad, okay? So remember, y'all got Thanksgiving break next week. When we come back that Monday, we're going to review for test 4. That Wednesday, when we come back, we're going to start reviewing for the final exam. Then you got one more Monday left of me, that last Monday. We're going to even review the final exam further. Okay. So we really want to study for that final, because the final is going to open on December 7th. So you'll have from December 7th till the 11th, which is that Sunday night, to do the final, okay? So it's going to open the 7th and be due the 11th. So y'all, it's down to crunch time. If you got homework you got to make up, you got a week and a half to do that before we come back. If you got any tests to make up, you're going to have to email me to open a test, okay? So Tanner, the final is 25 multiple choice. So for the final, my final exam review is pretty much just like y'all's final exam. So it's got like one question from each little section. But yeah, we're going to go over that and you'll be able to see where they're from and everything, okay? All right, y'all, so let me stop our share here. So let me stop this one and I'll send this out.